Welcome all to another session of Concept at Fingertips. This is Vidya, Physics faculty from Acharya Coaching. So today let us talk about resistance and the factors on which the resistance of a conductor depend upon. So resistance is the property of a conductor to resist the flow of electric current. So electric current means in a wire, electric current constitutes mainly because of electrons. So what is resistance? Resistance is the property of a conductor to resist the flow of electric current. So it is the property of a conductor to resist. Resist means to oppose the flow of electric current. So in a metallic wire, electric current is due to the flow of electrons. So the path of the electrons in a conductor is not a very smooth journey. So when an electron is moving through the conductor, when an electron is let's imagine this is a conductor, and when an electron tries to move through the conductor, then there will be so many atoms on the path. These atoms will attract these electrons. So the electrons will get attracted to different atoms, neighboring atoms, and all through the way, it will get opposition from the atoms. That means the attraction from the atoms, and it will be slowing down. So this contribute to the resistance of a conductor. This is the resistance of the conductor. So different materials offer different resistance to flow of electric current. Depending on the resistance offered, we can categorize the materials as conductors, resistors, and insulators. So in conductors, the opposition to the electric current is very low. That means resistance is very low. The property of resistance is very low in conductors. That means they provide very less opposition to the flow of electric current. In resistors are special components which we use to control the flow of current in a circuit. Yesterday we saw Ohm's law and we talked about resistors. So resistors offer less resistance when compared to insulators. But more resistance, but more when compared to conductors. So resistors means they fall under the they fall between the resistance of the resistors fall between that of conductors and insulators. Insulators offer very high resistance to the flow of electric current. Examples of insulators are glass, paper, etc. So they pass no electric current, like they are like completely they are opposing the electric current. But resistors, for example, resistors we use, like examples are nichrome wire, etc. So these offer very high resistance, and this is mainly used in heating applications. Conductors offer very low resistance, and they for examples are copper wires, aluminium, etc. And they are used mainly for transmission of electric current. Apart from these three categories, any material if you take, there are some factors on which its resistance depend upon. So let us see what are these factors. So for a particular temperature, for a constant temperature, resistance of a conductor depends on, first one, the length of the conductor. And then the cross-sectional area of the conductor. And then the nature of the material used to make the conductor. So these are the three factors on which resistance of a conductor depend upon. But here we have to ensure that we keep the temperature constant, because temperature variation can cause variation in resistance for even the same conductor. So let us see how these factors are affected, resistance is affected by these factors. So in order for that, we will so it is experimentally seen that the length of a conductor resistance varies proportional. Resistance is proportional to the length of a conductor. Let's denote the length of a conductor by L. Resistance varies directly with the length of the conductor. That means if there is a long conductor, it will have more resistance when all others are constant when compared to a short short conductor. So R is directly proportional to L. Again, the resistance is denoted by R. Resistance is inversely proportional to the cross-sectional area of the conductor. We denote cross-sectional area with capital A. So R is inversely proportional to A. So when you combine these two, we'll get R is proportional to L by A. And here we are going to change the proportionality sign to the equal to. That means R is equal to, we have to bring a constant rho L by A. Here this constant rho is the constant of proportionality, and we call it as resistivity. So this resistivity depends upon the type of the material. It does not depend upon the length or area or anything. It is the characteristic feature of the material. Resistivity is the characteristic feature of the material of the conductor. It's a characteristic feature of the material. So let us see what is the SI unit for a resistivity. SI unit for resistivity, we can find it out by using this formula. Rho is equal to RA by L. Just by rearranging this formula, we'll get resistivity. So from that, what is the SI unit? Ohm for resistance, meter square for area, meter for length. So by cancelling out meter square and meter, 1 meter, you'll get ohm meter. So ohm meter is the SI unit of resistivity. So we can see the resistivity varies according to material, and this is a table that is given in the NCERT textbook. So here it is given that electrical resistivity of some substance at 20 degrees Celsius. As I already told, resistance varies with temperature. So if you want to compare some substance resistance, we have to keep the temperature at a particular value. So here it is given as 20 degrees Celsius. And then this table shows different materials and resistivity of the material. So when you compare, see, first material given is the silver, and silver have a resistivity given as 1.6 into 10 to the power of -8. That means silver has, we already know silver is a very good conductor, right? It's the best conductor. So let's see the resistivity and let's analyze the effect of that. So 1.6 into 10 to the power of -8 ohm meter. That means this 1.6 divided by 10 to the power of 8, right? So when you compare that with an insulator, let's see, they have given these three categories here. They have categorized it, the three material categories: conductor, alloys, and insulator. Let us see insulator. We can take glass. So when you take glass, what is the resistivity given in the table? The resistivity is in the range 10 to the power of 10 to the power of 10 to 10 to the power of 14. See, when you compare these two, the resistivity of glass is a very high value when you compare with that of the silver. That means the silver has less opposition to the flow of electricity, or we know resistance is directly proportional to rho. From this equation we know that. So as rho increases, resistance increases. So that is why silver has very less rho when compared to that of glass. Here this resistivity is represented by the symbol rho. Okay, so when you compare with glass, it has a very less value. So if you compare the metals and alloys, let us compare the resistivity of metals and alloys. So the metals are given in the first part, right? They are conductors basically, and alloys, see, constantan, manganese, and nichrome. Nichrome is used in heating purposes, right? So it is an alloy of nickel, chromium, manganese, and iron. So it has a resistivity of 100 into 10 to the power of -6. So when you compare that, nichrome has a resistivity of 100 into 10 to the power of -6. And when you compare that with the silver, see, silver has 1.6 into 10 to the power of -8. So this has -8 and this has -6. So which one will have more resistivity? The resistivity of nichrome is greater than the resistivity of silver. So we can see that from this resistivity, we can see that the value of, like, the resistance given by the nichrome is much higher when compared to that of silver. So that is why alloys, when you compare the alloys with their constituent metals, they have more resistivity. And because of that, alloys are used in heating purposes where we need higher resistance. Again, why alloys are used in heating purposes is because of another reason too. And they have very high melting point. So when you heat a coil of wire, if it have very less melting point, means it will melt, right? So alloys have very high melting point and they don't burn. Alloys have high melting point and they don't burn or oxidize. Don't they don't oxidize easily, and then they offer high resistance. So all these things can be analyzed by using this table and the property called resistivity. So because of these properties, because of these resistivity and the properties of alloys, they are used in heating purposes. And what about the conductors? The copper and aluminum have very low resistivity and they are used as transmission. They are used in transmitting electric current. And we can see insulators. Insulators are used in many different applications. We'll see later. Insulators offer very high resistance for the path of electric current. So this topic is, I hope the topic is clear to you. We'll meet you in another session with another topic. Thank you.